So in last lecture we discussed about the maximum work, concept of maximum work, and you know that when the process is carried out isothermally and reversibly there is a maximum work, whereas work done in vacuum it is always zero. Now next point is zeroth law of thermodynamics. In order to understand zeroth law of thermodynamics, first of all you must know what is the meaning of thermal equilibrium. So you consider two closed systems A and B with a temperature TA and TB. TA it is the temperature of system A, and TB it is the temperature of system B, and both are the closed systems. And you know, in closed system there is a exchange of energy between system and surroundings, but not a matter. So these are the two closed systems, and TA and TB, these are the two respective temperatures. And important thing is, suppose temperature of system A it is greater than the temperature of system B, so TA is greater than TB. Now these two systems A and B, these are brought together and physically joined in a such a way that only energy transfer can occur and not a matter, like this. Now these two systems A and B, they brought together and there is a possibility of transfer of heat between system and these two systems and not a matter. And also you know that temperature of system A is greater than the temperature of system B, and you know heat is always transferred from hot body to cold body. When these two systems are in contact with each other, so transfer of heat will take place from hot body to cold body, and at a certain time, after some time, temperature of these two systems will be same, and that is temperature of A it is equal to temperature of B. So here the energy transfers from A to B till TA is equal to TB, and at this point these two systems are said to be in thermal equilibrium. These two systems A and B, these are said to be in thermal equilibrium. So this is what do you mean by thermal equilibrium. And you know that the transfer of energy from one system to another due to temperature difference, it is called as heat. So during or at the time of getting thermal equilibrium, there is a transfer of heat from one system to other system. Especially there is a transfer of energy in the form of heat from hot body to cold body, and at the end we get the thermal equilibrium. Two systems are in thermal equilibrium. So once you know the meaning of thermal equilibrium, now the statement of zeroth law of thermodynamics statement is very simple. Now zeroth law of thermodynamics, it states that if two or more systems are in thermal equilibrium, then any two systems taken separately are also in a thermal equilibrium with one another. Actually this statement is analogous to the concept you studied in maths. That is, suppose A is equal to B and B is equal to C, then A must be equal to C. It is like that. So statement, once again you try to learn or understand the statement of zeroth law of thermodynamics. If two or more systems are in thermal equilibrium, then any two systems taken separately are also in thermal equilibrium with one another. I will take an example. Suppose there are three systems A, B and C, and these three systems are in thermal equilibrium. That is, temperature of A it is equal to temperature of B, and this is equal to temperature of C. Now consider the two systems A and C. Now if TA is equal to TB is equal to TC. It means if these three systems are in thermal equilibrium, at that moment we say that system A is also in thermal equilibrium with C, that is TA is equal to TC, or system B, it is in thermal equilibrium with C, that is TB is equal to TC, or system A is in thermal equilibrium with B, that is TA is equal to TB. In other word, we say that if A and B, these are separately in thermal equilibrium with C, then A and B are also in thermal equilibrium. When A and B, these are in thermal equilibrium with C, then A and B, these two are also in thermal equilibrium with each other. So this is the zeroth law of thermodynamics. Now after this, next concept, that is the internal energy. What do you mean by internal energy? The total energy associated with system, it is called as internal energy. The total energy associated with system, it is called its internal energy, and it is the sum of kinetic and potential energy of the system. Or you know that the internal energy, it is a state function. You know the meaning of state function. Internal energy depends upon initial and final state and independent of path. Internal energy is also extensive property. It depends upon amount of substance present in that particular system. It is extensive property. So internal energy depends upon temperature, and therefore for isothermal process, internal energy is, or change in internal energy is always zero. Actually, it is difficult to determine the absolute internal energy, that is U, but change in internal energy, that is delta U, it can be obtained or calculated from the difference of internal energy of final state and initial state. So delta U, this is the change in internal energy. This can be obtained subtracting or taking difference between the internal energy of final state and initial state. So delta U is a change in internal energy. Delta U, U1, it is the internal energy in initial state, and U2, it is the internal energy of final state. And the internal energy, it is always equal to energy in the form of work plus energy in the form of heat. So sum of energy in the form of work and energy in the form of heat, that sum, it is equal to the internal energy. So this is the, what do you mean by internal energy? Now next point is first law of thermodynamics. So first of all, the statements of first law of thermodynamics, already you learn in earlier standards the statements of first law of thermodynamics, and the very famous statement according to first law of thermodynamics, energy can neither be created nor destroyed, but it can be converted from one form to other form. So this is one of the important statement, and actually this first law of thermodynamics, it is based on law of conservation of mass and energy. So this is the important statement. The same statement we can say like this: whenever one kind of energy is produced, an equivalent amount of another kind of energy must disappear. In other words, the total amount of energy of the universe always remains constant. Actually, universe, it is an isolated system, and therefore total energy of universe, it is always remains constant. Actually, within the universe there are several processes are taking place, but in these processes or during these processes there is a conversion of energy from one form to other form, so that total energy of universe remains constant. In another way, we can say that the total energy of an isolated system remains constant. Universe itself is an isolated system, and therefore total energy of an isolated system remains constant. And the last form of first law of thermodynamics or statement is, it is impossible to construct a machine which could produce work without consuming energy. This type of machine, it is called as perpetual motion machine, and it is not possible to construct perpetual motion machine or machine which produces work without consuming energy. This is highly possible. Whenever any machine does work, that work must be at the expense of some energy, and always there is a conversion of energy from one form to another form. And work is one form of energy. At the time of work, there may be a conversion from mechanical energy to work, electrical energy to work, chemical energy to work. So one energy must be converted into other energy or work, but it is not possible to get work without consuming any form of energy. This is highly impossible. So if that machine is there, then that machine will be called as perpetual motion machine. And first law of thermodynamics says that it is not possible to construct such a perpetual motion machine or machine which does work without consuming energy. So these are the important statements of the first law of thermodynamics, and actually meaning of all the various statements, it is same, and it is based on the fact that energy can neither be created nor be destroyed, but it can be converted from one form of energy to other form. Meaning of each and every statement is same.